Okay, and so we're back with part 2 of our week 12 lab video, and now we are going to be focusing on regression and scatter plots. So in this example, we are working with the dependent variable childs, how many children somebody has, and then we are looking at the independent variable age, how old someone is. Note that both of these are interval ratio variables, and that for any regression that you want to do, both of your variables need to be interval ratio level. So first, we're just getting the mean for childs. Okay, so we see that the mean for childs is 1.95. So the average number of children in our GSS sample is 1.95. The next thing we're doing is running a regression where our dependent variable is number of children and our independent variable is age. And so the research question that one would be asking here with these two variables is, what is the relationship between age and the number of children people have? The null hypothesis would be that there is no relationship between age and the number of children that people have. And a simple alternative or research hypothesis would be that there is a relationship between age and the number of children that people have. You could be more specific if you want to and say older people are more likely to have more children, but it's just fine to say that you think there is a relationship. And so we're running the regression and getting the results. And so let's just plug that in and chunk it. And so you get a lot of stuff here, and the part that I really want you to focus on is the part that starts with coefficients and that ends with that line signif codes. That's really all you need to be looking at when you are doing your interpretation of your regression results. And so what we're focusing on here is the line for age. So you get an estimate here. The estimate is telling us for each unit that our independent variable age changes, this is how much our dependent variable changes. And we notice that there's not a negative sign in front of it, so it's a positive coefficient here. And so how do we interpret this? For each year somebody ages, the number of children that they have is predicted to go up by 0.037 for rounding. Okay. The other thing that I want you to look at is over in this last column. The heading of it is PRT. Basically, this is a table, a part of the table that gives you the p-value or the probability that you would have gotten results like the ones that you did if there was actually no relationship between age and number of children. And so less than 2 exponent negative 16 is scientific notation. I'm going to do a quick search just so you can see what it actually is. It's this, okay? This is the value you're getting. So a ton of zeros, 2, very, very small fraction, only, very close to 0. When you have a figure like this, it means that there's almost no chance you would have gotten the results you did if the null hypothesis was correct. If there was no relationship between age and number of children, the chances are almost 0 that we would have gotten these results. And so if the chances are really small that we would have gotten results like this, if there's no relationship, then we conclude that there actually is a relationship. The other thing, if you get confused when you see this less than 2e to the negative 16, is look at the stars over here. The stars tell you the level of significance, and so we are typically interested in having a p-value of 0.05 or smaller, which corresponds to 95% confidence. And so 3 stars correspond to a level of significance of very small. Basically, they're saying 0, less than 0.001. So less than a 0.001% chance that we have gotten these results and there is no relationship. And so we can conclude that there is. So talk about the interpretation. Our coefficient for age is 0.037. This means that for each year someone ages, the number of children they have is predicted to go up by 0.037. The p-value for our coefficient is 2e-16, which corresponds to less than, let me just copy that. This means there is an extremely small chance we would have gotten these results if, in fact, there was no relationship between age and number of children. Therefore, we can conclude that there is a significant positive relationship between age and number of children. Okay, let's just look at that again. Our coefficient for age, which we got under the estimate column over here, is 0.037. Any estimate is telling you how much your dependent variable is changing based on a 1-unit change in your independent variable. Since age is measured in years, for each change in years of age, the number of children someone has is predicted to go up by 0.037. Then we looked at that last column with the probability, the p-value. Our p-value is this very, very, very small number. And this means that there's almost no chance that these results would have come to us if there was no relationship. And so then we conclude the opposite. We conclude that there is a relationship. And it's a positive, significant relationship between our 2 variables. And then the last thing we're going to do is show this in graph form by making a scatter plot. And so you can see here that I have the ggplot command, and there is a line that has the title information. And so for your own scatter plot, you're going to want to fill in your variables. And then in the labels line, you're going to fill in the names of your independent and dependent variables. X stands for your independent variable, Y is for your dependent variable. Let's run this chunk. Sure, there are going to be error messages as always. We don't need to worry about them. We're just going to focus over here. And so you can see going across the bottom, you have the years of age. Going up the side are the number of children, and then this line represents the relationship between age and number of children. And so to write an interpretation of this, the regression line has a positive slope meaning that as age increases, so does the number of children that people have. Okay? If that line was going downwards, it would be a negative relationship. If the line was flat, it would mean that there's only a very slight relationship or no relationship at all. But we see that someone who's 20 years old is predicted to have about 1 kid based on this graph, and someone who's 80 is predicted to have had about 3 kids in their lifetime. So as age goes up, so does the number of children that people have. So that's really all there is to regression. It's looking at 2 interval ratio variables and the relationship that they have between them. And we're just showing it in 2 different ways, but they're going to be in agreement with each other. You know, if you have a graph that shows this slope of the line going up positively, then your regression equation results are going to have a positive coefficient for your independent variable. There are 2 different ways of showing that there is a relationship between our 2 variables. So that's all you need to know for regression. And we'll go ahead and save this. And then we'll do our knitting to Word and uploading it over to our lab assignment upload. And then we're in good shape.